The Voronoi diagram below shows four supermarkets represented by points with coordinates A, 0, 0, B, 6, 0, C, 0, 6, and D, 2, 2. The vertices X, Y, Z are also shown. All distances are measured in kilometers. Part A asks us to find the midpoint of BD. So here's B, here's D. The midpoint between these two values would be something right about here. So midpoint is given to us in the formula booklet. I'll write it out here. Right here, I suppose. Midpoint is given as the halfway value between the x's and the y's. So midpoint is given as x1 plus x2 over 2 and y1 plus y2 over 2. So I think sometimes, let's actually label these. So D itself is 2, 2, and B was 6, 0. I'm going to call these x1 and y1 respectively. Sometimes that helps keep track of things. So let's go ahead and substitute these values. So essentially the average of the x's, the average of the y's. x1 plus x2, this is 2 plus 6 over 2. And y1 plus y2 is going to be 2 plus 0 over 2. Simplified, 8 over 2 is 4, and 2 over 2 is 1. Okay, so we know this midpoint value. Here we go. Find the equation of xz. So essentially the perpendicular bisector between D and B. We've already done some work and found the midpoint right here. What we're going to need to do is find the slope of a line, use that to find the perpendicular, and then we can substitute this midpoint to find the y-intercept. Common question, shows up enough, and it's often between around 5 marks or so, between 4 and 6 marks. So the whole process is potentially potentially 5 marks, and it shows up often enough, and the procedure is always so similar that I think this is one of the good ones to get a handle on, I suppose. Okay, so let's work through it. Here, let's draw the slope between D and B. So here is dB right here. Let's find the slope of this line. Okay, so what is the slope of a line? Slope of a line is given by m, and it is equal to y2 minus y1 over x2 minus x1, or essentially change in y over change in x. Okay, so we already labeled y2 and y1 and so let's go ahead and substitute y2 minus y1 over x2 minus x1. Simplifying this is going to be negative 2 over 4, or simplifying once again is negative 1/2. Okay, so that looks pretty reasonable, definitely a negative slope. So for every move to the right, we go down by 1/2. All right, so that's the slope of this line, but we want to find the slope of this line. So what can we say? Being that this is a perpendicular bisector, we know that the slope of xz will itself be perpendicular. So if m itself is equal to negative 1/2, what is m perp? What is a perpendicular? Remember our, I guess procedure, I suppose. In finding a perpendicular bisector, switch the top and the bottom and multiply by a negative. So m perp is now 2 over 1. Used to be negative 1/2. Negative times a negative is positive. So it's just 2 over 1 or 2. Okay, so we've got our slope. I'm going to clean this up here. I want to keep the midpoint. Actually, I'll do this. So keep the midpoint. It's important. We're going to need that, but let's look at the progress on the way to finding this equation of a perpendicular bisector. So An equation of a line is given by y equals mx plus b. We already know the slope of this line right here. It is 2. So y is equal to 2x plus, and now we need to find b, the y-intercept. Don't know it yet, but we do know a point on the line. We know this midpoint, this 4, 1. And what that does for us, since we know a point on the line, we know it's a solution to this equation. We know it's a solution to, well, this line, I suppose, the equation of this line. So what that means is we can substitute the x, y values into this equation, and then we'd go from having 3 unknowns, x, y, and b, to just one unknown, b. One equation, one unknown, we can then solve. So y is equal to 1, x is equal to 4, and then plus b. We're drawing from these 2 points, x and y. Okay, now we've got an equation. We can end solve this, but I'm going to work this out. 2 times 4 is 8 plus b. Bringing this to the other side, we have b is equal to negative 7. All right, so going back up into this equation of a line, what do we have? We know that b itself is equal to negative 7. So I'm going to replace this with negative 7. So y is equal to mx plus b. M was 2. B we found to be equal to negative 7. And there's our equation of a line. Okay. Good. The equation of xy is y equals 2 minus x. So this is xy right here. And the equation of yz is y equals 0.5x plus 3.5. So this equation right here. Find the coordinates of x. 3-mark question. Okay. So the IB actually doesn't often do this. That is to say, they don't often throw in distractors. So this right here, this equation of xy, where is xy, xy, xy? No, we do need xy. Sorry, this yz right here. This yz is not relevant, actually. So the IB doesn't often throw in distractors. But maybe this is from 2022, and maybe there was a different kind of outlook then, I suppose. But they don't often do this. We don't actually need this. We don't need yz. If we want to find the value of x, what is the value of x? It's the intersection point between xz, which we found here, and this point right here. So this equation, xy. So once again, what is x? It's the intersection point between xz and xy. 2 different ways we can do this. We can set this up graphically and then just solve for the intersection, or we can solve this as a system of linear equations. So we know y is equal to 2x minus 7, and we also have y is equal to 2 minus x. So we can actually do this with algebra, but let's use the system of linear equations. So let's go to the calculator. Let's go menu, and then we'll go algebra and solve system of linear equations. 2 equations in terms of x and y. And the first one is y is equal to 2x minus 7. And the other one is y is equal to 2 minus x. And the intersection point is 3, negative 1. So I think that's okay. I was thinking whether we should look at the other method, and I suppose we can. So if you want to graph this as well, 2x minus 7, and then graph entry, and then 2 minus x, and then analyze graph intersection, 3 minus 1 again. So either way, they're both equivalent and both equally quick. Okay, so find the coordinates of x. Let's write this out. Coordinates are 3, negative 1. Okay. The coordinates of y are negative 1, 3, and the coordinates of z are 7, 7. So y, and then all the way up here is z. Determine the exact length of xy. Okay. So essentially this is distance formula. So determine the exact length of YZ. So let me just put this. Y is -1, 3, and Z is 7, 7. So I'm actually just going to write that out. Y is -1, 3, and Z is equal to 7, 7. Okay, so a few different ways we can solve this. I think the easiest way is to use the distance formula. Actually, the easiest way might be to use Pythagorean theorem, which is essentially the distance formula. But let's go ahead and use the distance formula. Distance formula is given to us in the formula booklet. Looks like this. Y2 minus Y1 squared plus X2 minus X1 squared. Let's go ahead and label these. That'll be okay. And then we'll use these to substitute. Okay. So Y2 minus Y1. So this would be 7 minus 3 squared. X2 minus X1. This will be 7 minus, and then just be careful here, it's minus 1. So negative and a negative, this would become positive, of course. All right, and then we can write that out within our calculator. I want to simplify this just a little, actually. 7 minus 3, that's equal to 4 squared. And 7 minus minus 1. Remember, this will turn positive right here. So essentially this will be 8 squared. Okay, so let's go to the calculator and work this out. Set up a square root, and I'm actually going to use brackets and that original without simplification, just to, I guess, show you what it would look like if you needed to write out with the brackets, -1 and so on. And this is squared. 7 minus 3 squared, 7 minus minus 1, squaring this all right here. All right, 8.94427. So writing that out, we have 8.94427, or 8.94. Okay, I think we are good. So, oh, I'm sorry. So there's one thing that I had not misread, but I guess read too quickly. It says determine the exact length, and the exact length here. So, exact length doesn't mean decimals. It means with square roots, we just leave it as what's called an irrational number, or surd form. So going back to here, this we are one step away from writing it out is an exact number. So I'm going to erase this decimal right here. 4 squared is equal to 16, and 8 squared is equal to 64. Therefore, we have square root of 80. Okay, so that would be our exact length. So that was my mistake. Exact length is root 80. So no decimals, leave it as a surd form. Contained within this is an infinite set of decimals trailing off, and it's as accurate as we can possibly be. Okay, I think that's good. I was thinking, yeah, maybe I will. I hope this isn't too long. You can always, of course, skip ahead. But the distance formula is essentially Pythagorean theorem. So another way that you could do this is draw a triangle. So I think I can do just a little better than that. You can draw a triangle. So right angle triangle right here. We go from -1 all the way to 7. We travel a distance of 8. We go from 3 all the way to 7. We travel a distance of 4. Pythagorean theorem, a squared plus b squared equals c squared. That is to say 8 squared plus 4 squared equals c squared. That's this length right here. We don't want c squared, we just want c. How can we get rid of a square root? Or sorry, a square by taking the square root. And now we have that exact same thing. 8 squared plus 4 squared equals c. And that'll turn into root 80. So I think that's often a nice way. Distance formula, essentially Pythagorean theorem actually. Okay, E. Given that the exact length of xy is root 32, find the size of xyz in degrees. So xy is root 32. So this length right here is equal to root 32. This length we found to be equal to root 80. Given the exact length of xy, find the size of xyz. So xyz is going to be this right here. So xyz. Okay. So how can we do that? Usually we need, so we're in the realm of non-right angle trigonometry. It's just asking ourselves, can we use the sine formula? Do we have angle opposite side length, angle opposite side length? And we don't have any other actual angles, so we're not going to be able to use the sine. Can we use the cosine? We can, but we need to find this side length. Cosine is 3 side lengths and an angle. So is there any point where we found out the side length of xz? So I think we're actually going to need to find the, I think we're actually going to find the area at all? I don't think we did. So it looks like we're actually going to need to find the distance of xz, which seems, to be honest, let's see. Can we know what yz is. Is there any other information within here that will tell us that, I'm just wondering, because it seems like a repetitive skill. They already asked us to use the distance formula. So it's very rare for the IB to ask you to do the same skill twice when they've already assessed for it. So, okay. Well, I think we're actually going to need to find the length of xz right here. So let's do that. Let's use the Pythagorean method because I think that's a little quicker. So what is point x? X was, did they tell us what x was? I thought we had the coordinate of x, 3, 1, we found it earlier. So 3, -1. Let's use this Pythagorean method and just create a right angle triangle. Okay, so in terms of x, we're at 3 and we go to 7. That means we travel a distance of 4. We're at -1. We're at -1 and we go up to 7. That means we travel a distance of 8. So what we're going to have is a squared plus b squared equals c squared. 4 squared plus 8 squared equals, and then we'll call this c, we imagine. C squared, we don't want c squared, we just want c, taking the square root. Whoops. And this is actually going to give us 16 plus 64, once again, which is root 80. So root 80 is equal to c, which is kind of interesting because it's an isosceles. So they're both root 80. Interesting. Okay. So now we've got a triangle, we know all 3 side lengths, and we've got this angle here. So let's go and use our cosine rule. I'm going to erase this once again, just to clear up some space. And I think I can erase this as well. Okay, so what is our cosine rule? This is given to us in the formula booklet. There's actually 2 different cosine rules, so I'm going to bring it up. Here we go. where are we now? Here we go. So here's our cosine rule, some remnants from before. Cosine rule is given as c squared equals a squared plus b squared minus 2bc cos a. And then an equivalent form right here. This is if we want the angle by itself. Since we're going to end solve either way, I think this one is generally pretty easier, just because it helps us show the pairing of the angle and side length. So let's go back, write this out. Here's our cosine rule. A squared equals b squared plus c squared, which is actually Pythagorean with this little change at the end, minus 2bc cos a. We see this a appears twice. What does that mean? It means we're matching up a side length with its opposite angle. So that means these two have to match up. Let's substitute. So a squared is root 80 squared plus b squared plus c squared. B squared plus c squared, doesn't matter which ones we call b squared and c squared in terms of the order. That is to say, we could have put 32 plus 80, and that would have been okay. Minus 2 times root 80 times root 32 times cos, and we don't know what this theta value is. Okay, I forgot to square these. Okay, a squared equals b squared plus c squared minus 2bc cos a. All right. Now we've got an equation just in terms of one unknown. We can go ahead and solve this. So let's go to the calculator, work that out. Menu, algebra, numerical solve. And then, to be honest, we don't actually need root 80 since we're going to square it. If we square these values, it essentially gets rid of the root. So we can actually just write, 80. So let's do that. So 80 is equal, I'm not sure, I don't want to make things more confusing. So let's say root 80 squared is equal to, and then once again, we had root 80 squared, a squared plus b squared, and b squared was again root 32, which we want to square. So a squared equals b squared plus c squared minus 2, and now we have root 80, 2b c, just root 32, 2bc, and cos a. And we can just call it a like this. All right, now ask the calculator to solve for a, and I think we're good. Make sure you're in degrees. And here we have 71.565 degrees. Okay. Let's go on. So, let's write that out. Find the size of xyz in degrees. So we said this was 71.5651 or 71.6 degrees. Nice way to check. Remember, this is an isosceles, so this angle equals this angle. Total angles within a triangle equals 180. So if, for example, we had anything above 90, then we would have said, okay, our 180 is already used up for these bottom angles. So the fact that we have 71.6 is good because, well, it doesn't immediately mean that we've used up all of our angles, or that our angle in our triangle adds to something greater than 180, which would be impossible. Okay, part F, hence find the area of triangle XYZ. Okay, so let's write that out here, I guess. Area of a non-right angle triangle, this is given to us in the formula booklet. Area is equal to half AB sine C. What does that mean in the context of our triangles? If this is, maybe I can write a more irregular triangle. Let's see. There, hopefully that's okay. Okay, so let's say this is A, B, and C. Opposite angles, opposite side lengths, they just take capitals. If we have two side lengths and an included angle, then we can use the area formula. And that's exactly what we have here. We have two side lengths, and we know this angle right here. So let's go ahead and do that. So I think I'm actually going to bring this up just because all of the work is there and it's maybe a nicer visual. Area is equal to half AB sine C. So half A is root 80, B is root 32, and then the angle in between we found was 71.6. And this should give us the area of this triangle. So let's write it out. So half, and then we have root 80 times root 32, and then this is times 71 sine 71.6. And maybe I'll grab a few more degrees here. 5651. All right, so it is equal to 24. The area is equal to 24. Interesting. Okay. Let's continue on. A town planner believes that the larger the area of the Voronoi cell XYZ, the more people will shop at supermarket D. State one criticism of this interpretation. Okay, so essentially what they're saying is if this area within D, this cell increases, more people are going to shop. And I suppose it's not a bad kind of intuition, but the problem is we don't know much about what's on the ground. So it doesn't say anything about population density, for one. We don't know if this is really sparsely populated for some reason. And it also doesn't say about like access to roads. Like this could be like sparsely populated and like mountainous or like a desert area, and there might not be a lot of people within here. So first, it doesn't say anything about population density, and the second was straight line distance might not be the greatest indication of how convenient or how close something is. So here, for example, straight line distance would be closer to D, but maybe you have to like take some winding road through the mountains to get to it, whereas this is, a highway. So in this case, let's look at the mark scheme actually, see what they say. So any sensible answer, such as there might be other factors than proximity, which is a little vague to be honest, but a larger area does not necessarily result in an increase in population. It's good. The supermarkets might be specialized, okay. Transport links might not be represented by straight line Euclidean distances. Okay, so either of those would work. I think population density and straight line distances is the ones that I would go with, but any sensible answer, as long as we draw context. The IB kind of went away from any sensible answer to looking at more context. So I think later on it would be something related to transport links or population density.